here's a cool math problem I have for you guys. In triangle ABC, BC is 30, AC is 20, and AD and BE. So we're going to draw more line points now. So AD and BE are two medians on BC and AC, respectively, with AD being the perpendicular bisector to BE by the length of AB. So I'm going to start by drawing this triangle after I open the cap. Okay, so triangle ABC. So C is used in both of them as the lengths over here, and AC is shorter than BC. So I'm going to put it like this. I'm going to have this be 30 and this be 20. Now AD is going to be the perpendicular bisector. We're going to have that right there. And then E is going to go like that. Now, it's important to note that these form right triangles. So in this problem, we're going to be able to use the Pythagorean Theorem. Now, let's say I say AD is 3x and BC and BE is going to be, my E's are looking a little fuzzy, are 3y. That would mean that, here, I'll call this point G right over here. That would mean that from A to G, we would have 2x. Right here we'd have 1x, and then for BE, from B to G, we would have y, and over here we would have 2y. Now, since these are split into two, that means that this right here is 15, and this right here is 10. So now we can just use the Pythagorean Theorem and get some places with it, doing big things with it. So we have, here, I'll write it over here. I'll say y squared plus 2x quantity squared is equal to 10 squared. And then over here we have x squared plus 2y squared is equal to 15 squared. So when we add those together, we have 5y squared plus 5x squared is equal to, now 10 squared is 100, 15 squared, quick maths, 225. It's actually a trick to remember, like 5 times 15 times 15, 25 times 25, 35, 45, and on and on. I think I forgot it though, but anyways, it's a thing, so ta-da. So now we know this when we divide by 5. 325 divided by 5, just so that we can just get the plain xy squared terms. We get 6 minus 30, we have 2, bring down the 5, 65. So now I can say y squared plus x squared is equal to 65. What am I doing? 65. Okay, that's going to be pretty important. The next step to do is in the problem, I need to find the length of AB. Now AB is, we can just use the Pythagorean theorem for that. AB squared is 2x quantity squared plus 2y quantity squared. And that's 4x squared plus 4y squared. So we need to bring that to there, and then we'll have what AB squared is. So all we have to do is multiply by 4 for it to be in the 4y and the 4x squared form. So 65 times 4 is equal to 20, that is 24, this is 26. So 4y squared plus 4x squared is equal to 260, which is AB squared. Now, fun fact, you don't actually need to multiply 4 times 65 because you're going to take the square root of it and you're going to take stuff out of the square root. So this is just food for thought. I'm just going to keep it as 4 times 65 because if a squared is equal to 4 times 55, or AB is equal to 4 times 65. AB squared is equal to 4 times 65. Means that AB is equal to the square root of 4 times 65. Now that's 4 can be broken up into 2 and 2, so AB is equal to 2 square root 65. Well, that's a really cool problem. I feel like I said that a bunch of times. Anyways, thank you very much for watching, and goodbye.